We consider this differential equation here, where r is the independent variable and z is the dependent. So again, our goal would be to solve for z equals some value. We look for opportunities to separate this, and it's fairly straightforward. We can bring the entire denominator here up to the left-hand side, and it would then multiply the dz part. And we can bring the dr part up on the other side, and we would have the right-hand side, which is only based on r and no z's. So we've been able to successfully separate the variables, and that leads us to the next step, which is to integrate both sides separately. So we throw an integral sign in front of both sides, and we just go term by term and integrate. We need to differentiate sine of z to get cos, and e to the z to get e to the z. On the right-hand side, we would have r to the power of 6, with the 6 in front and a 6 divider. Those will cancel in a second. Minus 2r squared over 2, plus an r, plus some constant. And again, we simply put that on the right-hand side for convenience. It could be on either side. Now, in this particular scenario, even though our goal is to find z equals, sometimes it will not be possible. In particular, if you look at this left-hand side, we're not going to be able to successfully isolate this for z. We need to do arc sines as well as lns, and they're not going to go together at all. The underlying issue is that we have z in two places inside complicated functions. And so the best we can do is stop right here. And what we'd call this is an implicit solution. It's implicit, just like an implicit function has x and y related, but not with one defined in terms of the other explicitly. Here we have z's and r's. If you told me what r was, I might be able to figure out a value of z or a couple values of z, but it's not, if you tell me r, I get z immediately. And in this case here, there's nothing else we can do with that. By separating the variables, this is what we get as the next stage, and that's as good as it gets in terms of moving forward. In the course, we won't see a lot of this, but it's important to recognize that there are limitations on what we can do depending on the equation we've been provided with to solve. An interesting point, though, when we have our solution here, sine of z plus e to the z equals r to the 6th minus r squared plus r plus c, is that we can still verify it if we want. And again, it's never a bad idea because this seems a little exotic, let's be honest. We can verify that, but the only difference is we'll have to use implicit derivatives. So working with that, what we're going to have to do is take the derivative of this expression here and see if we can solve for dz dr. So the left-hand side is dz dr, and that is going to require some implicit derivatives over here. We're going to take the derivative with respect to r of the left and the derivative with respect to r of the right, and bring that down here. We're going to get sine of z. Oh, no, when we take a derivative implicitly, we'll get a cos of z. Then the derivative of the inside would be dz dr, plus the derivative of e to the z is e to the z, times dz dr, and the right-hand side, the derivative with respect to r is much easier here. It's just 6r to the 5 minus 2r plus 1 plus 0. And then we recognize, oh, I've got a common factor here of dz dr, and everything on the right-hand side stays the same. The terms that went with the dz dr are a cos and an exponential, and we can just put those together on the left and then bring them down to the right-hand side, and we recognize, hey, that is my left-hand side, and that happens to exactly equal the right-hand side, so we do actually have a solution. Again, it's not the way we'd prefer it, but in this case it's the best we can do because the relationship can't be isolated for z equals. In terms of working with these kinds of expressions in a test scenario, we would typically let you know that an implicit solution is sufficient for this kind of problem. Most problems will expect you to get to the z equals stage unless otherwise specified.